Alright, what's up guys? In this video, I'm going to pick up some calculus here. It's going to be another integration practice video. This is going to be example number 23 of the integration practice series here. Alright, so we're just asked to integrate, or we're asked to evaluate the integral of this inverse trig function, tangent to the negative first of x dx, which is the same thing as arctangent of x. So anytime you have an inverse trig function that you need to integrate that's just sitting in there by itself with nothing else, it's going to be integration by parts, very similar to how we use integration by parts to deal with ln of x. So we're going to apply integration by parts for this. Now just to note, integration by parts using the abbreviation there. And the formula for it is the integral of u dv is equal to uv minus the integral of v du. So we know we need u, and we know we need dv. And it's pretty obvious to tell what the u is. Well, the u is just going to be arctangent of x, because if dv was arctangent of x, then we would need to know the answer ahead of time. So clearly, u will be arctan. I like using arctan instead of tangent to the negative first. It's the same thing. It's just a personal preference. But I'm just going to use arctan of x. And so what that means is that dv is everything else. So dv would just be dx. Alright, so we need du. So that's just the derivative of arctangent of x. Remember, the derivative of arctangent of x is just going to be 1 over 1 plus x squared. Don't forget to multiply it by dx. And then to get v, we integrate dv. So that's the antiderivative of dx, which is just x. So just a process of following the formula. So we'll have x multiplied by arctangent of x, and we'll subtract that from v du. So v du, that'll give me x over x squared plus 1 integrated with respect to x. Okay. So now we just need to integrate x over x squared plus 1 with respect to x. And that's just going to be another natural logarithm, but if you don't know how to get the answer to this, let's just go through and do it. We'll do a u substitution. Picking u to be x squared plus 1, differentiating it, so du, we'll get 2x dx. And we'll get 1 over 2x du is equal to dx. So the 1/2 is a constant, can be pulled out front. And what that leaves us on the inside is the antiderivative of 1 over u du. We can plug the u back in, multiply by 1/2 by applying the constant multiple rule. So we'll get 1/2 ln absolute value, and I'm going to put the u back in there, which is x squared plus 1, and that would essentially be the antiderivative to x over x squared plus 1. Technically plus c, but we're going to add a plus c at the end, so we don't need to add it there. So we're pretty much already done with the integral. All we have to do is just tackle on our constant of integration. So our final answer for this integral, we just got to connect everything. We were just simply integrating arctan of x. So our answer to this integral is just going to be x multiplied by arctangent of x, or arctan of x. And it'll be minus 1 over 2 ln absolute value x squared plus 1 and add your constant of integration. And it's just as simple as that. Alright. So hopefully that was one that was relatively straightforward. Again, we've done plenty of videos. Alright, so if you guys got any questions, let me know. I will see y'all next time.